Welcome to Evo 10 ECU Flash Training Part 9. In this video, we're going to take a look at dialing in our closed-loop fuel delivery. Now, we're going to find that we can utilize our short and long-term fuel trims that we've learned and talked about in our previous video, taking a look at the closed and open loop. We can take our data logs that we capture in Evo Scan, and we're going to be importing them into our Megalog viewer. We can then take that data, create some custom fields, some custom math equations in our Megalog viewer, and being able to build what's called a histogram table. The histogram table is going to allow us to very efficiently and quickly dial in our fuel so that our fuel delivery is going to be spot on and our short and long-term trims are going to be as close to zero as possible, indicating that our fuel delivery is exactly how it should be coming from the ECU. So there's going to be a lot of things to cover here. Without further wait, let's jump into this video so we can check this out.
Okay, so let's get started. We're going to be taking a look at doing part throttle fuel tuning in our Evo 10 applications. Now, the part throttle tuning is going to take the most amount of time. It's going to be the most time-consuming thing that we do. It is going to be very specific in what tables we actually edit. There's going to be some rules that we have to follow in order to make sure that our load calculations are in line and that our fuel is being delivered properly in idle and cruise part throttle situations. Let's jump in here and talk about what we have for tables to edit and work with, and then we'll move into taking a look at what we need to data log, and then also taking a look at some specific data logs and learning how to work with that data to analyze it so that we know what to change and where to go into our file to actually update and tune things. So first and foremost, I have a 2010 USDM SST MR style calibration file open. You can follow along with this particular calibration, which is a 5558005, or you can grab another file. They're all going to be relatively similar as far as going in and working with this in this process. If we scroll down here and we're going to go into our fuel related area, we need to take a look at some specific tables here. So we're going to be looking at our MAF tables. We're going to have our 3 different mass airflow tables. We went through this in our other video, but we're going to go through this again here. So we're going to bring up our MAF scaling tables here. We're going to find that these are going to be what we measure the amount of airflow coming in from the mass airflow sensor entering the engine. It's going to be in a scale of 0 to 5 volts from our MAF sensor. It'll look up at a particular voltage what a airflow amount's going to be, and then it's going to report that to the ECU. Now, this is only going to be the airflow that's coming into the engine. We're going to find that in order to get air mass, we need to go then taking a look at the intake air temperature and the baro pressure sensor. That is going to be encompassing our density that's entering the engine. So this will be the volume, the IAT and baro style calculations or the readings will be then the density. By knowing the volume and the density, we would know what the mass would be, in this case, air mass. So we have an underlying equation, we've talked about this before. Fuel mass is equal to air mass divided by target air fuel. In this case, if we know what the air mass would be in part throttle idle cruise situations, we're going to have a fixed target air fuel of 14.7 to 1. That's where we're going to operate in closed loop. We've talked about open and closed loop. We'll find that it's going to be taking a look at the front O2 sensor, which is going to be running about a half volt on that 0 to 1 volt scale. Half volt meaning that's 14.7 to 1. So we're going to be able to calculate what the fuel mass is going to be and then deliver a proper injector pulse width based on our fuel calculations going on with our fuel injector data that we've programmed. So this is going to be one portion of some of the calculations that are going on. We're also going to have 3 tables here that are called map base calc tables. These are going to be essentially a speed density style calculation. Now, I'm going to leave just one of these open. We don't have to have all 3 of these open. We're going to get the idea of just having a singular table. This table here is going to be used for load calculation, not necessarily for actual speed density calculation, where it's going to be estimating the airflow coming in. Remember, we've talked about the difference here where we're measuring the airflow with a mass airflow sensor. With a MAP sensor, this is based on MAP pressure here from our MAP pressure sensor. Engine RPM, MAP pressure, the values in the table here, these would be an estimation of the airflow coming in. By knowing then the intake air and the baro pressure, we'd figure out the density. Putting those 2 together, we then would know the air mass. This would be what we'd estimate the air mass to be. This would be the actual air mass we're measuring. So it's going to have redundant calculations going on in any given time. We can track what's going on based on MAF calcs and MAP calcs. We'll talk about that here in just a little bit. We can actually figure out what mode it's going to be in. Is it going to be in mass airflow mode, or is it going to be in speed density mode? Now, there is 3 tables here, and they are redundant as far as the tables go. we normally want to make all the values in all of our map calc tables.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.